And welcome to Interesting Stuff. My name is G. I'm your host, and I hope you are going to get something out of this little educational supplement. So, wherever you are, whatever you're doing, focus. Please pay attention. Get yourself a pen and paper if you need to. And today we're going to talk about splitting the atom. So let's dive right in. Now, science, of course, is the study of everything in reverse, which sounds a little bit strange. What do you mean? Well, to understand how it moves forward, you have to look at where it came from. You can't really see the future, but you can see what evidence you have, what exists from the past. So what scientists do is they look at what happened and they try to put the pieces of the puzzle together and use that to predict what's going to happen the next time. And that's the scientific method. That's the process. We need a bit of logic in our lives. And that's what's built up everything great that we have around about us in the modern world. Anyway, onto the atom. So Ernest Rutherford was a professor at Manchester University. Now, this is going back to the early 20th century, so we're looking at around 1909. He had a number of students, two specifically, Marsden and Geiger, who were using a type of radiation known as alpha particles. They were using it to bombard a piece of thin gold foil. And what they discovered is most of the particles flew through the foil, but occasionally one was deflected to the side or even bounced back in the direction it had come from. These deflections showed up on a specially coated plate. It was coated with zinc sulfate that flashed when it was hit by high energy particles. Now, Rutherford describes this as basically having something like a bazooka and firing it at a tissue paper and then discovering that the rocket actually comes back to you, which was it was pretty surprising for the men at the time. And you can imagine that their excitement about learning about the origins of the universe and how useful this could be for science and the world around about them. Anyway, Rutherford concluded that the alpha particles, which carried a positive electric charge, had been repulsed by a strong positive charge in the atoms of the foil. And how I think about this is if you've got like magnets, which have like two opposite poles, you've got the north side and the south side, and you try to put the two norths together, they repel each other. And that's what he was imagining there was happening. Now, it would be nice if this was an entirely new idea, but if we take a step back into history for a moment, we discover that the Greek philosopher Democritus was the first to propose to the world that actually perhaps the universe was made up of tiny, indivisible, indestructible particles, which he called atoms, from the Greek atomos, or indivisible. See, he believed that atoms were differently shaped and organized depending upon the material they made up. It was pretty revolutionary for the time, it appears. And what he said was these differently shaped atoms were organized depending upon whichever kind of material you could observe, basically. And his theory was dismissed by everybody. That the great scientific world that we live in. Hey, here's a great idea. Maybe the Earth goes round the sun instead of the sun going round the Earth. Oh, crazy man! Expel him. What do you call it when you slander? That's it. Slander him. Burn him. A lot of bad things happen to a lot of good people down throughout history. It's really crazy. And his theory was dismissed by Socrates and most other Greek scientists and philosophers. and was not taken seriously again until the 17th century. So welcome to 1,000+ years of darkness, where we had the solutions and then we lost them. I often wonder about that symbol for the medical establishment and medicine. It's like two snakes around a post or something like that, and it looks like the DNA helix, and that symbol's been used for probably thousands of years. And I wonder if perhaps in the past, at some point in time, people knew or had some special knowledge, and then maybe it got lost, as a lot of things get lost in history. Who knows? So much has been lost. Anyway, back to our story of the atom. So the first proof of the existence of atoms was put forward in 1803 by an English Quaker. His name was John Dalton, and he carried out experiments with gases in order to investigate the chemical elements of the gases. These he discovered were substances that cannot be broken down into anything simpler. So he was looking for the origin, or the simplest form of the gas or the substance. He declared that each element had a distinctive type of atom, different from the atoms of any other element, and the atoms of each element had a different mass. It's very interesting to measure the weights of things so that we can discover what they consist of. Now, another English scientist, Joseph John Thompson, made a vital addition to the understanding of atoms as well in 1897, when he showed that the atom, far from being a solid structure, as Dalton had believed, actually contained smaller particles. And Thompson, like many other scientists of the period, experimented by passing an electric current through a glass vacuum tube. This electricity produced what we call cathode rays. And these rays, or through these rays, he was able to deduce that there were particles which he called electrons. And so science took another leap forward. Now, Ernest Rutherford, who's the man that we started with, who was at the Manchester University, he made a second breakthrough in terms of understanding the atom when he smashed the nucleus of the atom in an experiment at Cambridge University. What basically happened, I'm not going to describe the long experiment. You can go and study it and see how it worked for yourself, but I want to keep this as brief as possible. Basically, in his experiment, he saw flashes of light on a screen, suggesting that some particles were escaping from his experiment. And science is the recording of information. So he recorded this, and then he philosophized on what it actually meant. And he concluded that these flashes were hydrogen nuclei traveling at super high speed. He basically seemed to have achieved what alchemists had struggled to do for centuries, and transmuted matter. That's a great word, isn't it? Transmuted. In 1919, he presented his findings in the celebrated philosophical magazine. Interesting, a philosophy magazine. Was that science? Were science and philosophy interrelated at that time? Very interesting. He concluded that hydrogen nuclei, later called protons, were present in the nucleus of every element. Now, it's pretty amazing to me that the universe appears to be made of infinitely smaller parts. The more we study it, the more we learn about it. It's also pretty interesting, that difference between the solid and the non-solid elements and particles. If atoms have these parts that are moving and that are not fixed and that are not solid, how are solid objects actually created in the universe that we experience around about us? So many questions. And science is evolving. So hopefully, since then, we've developed our knowledge, and we know much more today. And hopefully we take these steps forward and learn much more in the future. And the more we understand the universe around about us, the more we can use it to help us make a better world and a better planet for everybody. And maybe if you look into this a bit more, you'll get into the topic, and who knows, maybe one day you'll be a scientist too. The future's not written; it's up to you. So go out there and do what you need to do. Thanks very much for tuning in. This is interesting stuff. Let me know. Let me know what I should cover. Let me know what topic is interesting for you. I hope you picked up something from this. I will stick a few questions under the link to this. This is audio video. There's no specific video, but I'll make an image to go with it, and review, refresh the information. Maybe you picked up some new knowledge. Who knows? That's it. Wherever you are, have a great day. Take care.